In this tutorial, we're going to learn about the electric current. The electric current is the rate of flow of electric charge in an electric circuit. Electric charges are also called electrons, so we can also say that the electric current is the drift of free electrons in a material. In this video, we have a good conductor of electricity. These have a lot of free electrons that are in the last shell of the atom. These electrons could move out of the atom and easily inside the matter. Like we see here, how they're moving. Every time two electrons meet, they're gonna repel each other because they have opposite charge, because they have the same charge. As we see here in this picture, the atoms are represented by orange circles and the electrons are represented by blue circles. The electrons are moving freely inside the matter. Here we say that this is a random motion of electrons. Now, when we connect this material to a battery, electrons will move towards the positive charge of the battery, like we see in this picture. The free electrons move away from negative end to the positive end. And we can see here how it is represented. First, the electrons are moving randomly. After connecting to a battery, you can see how it's moving from the negative to the positive side of the battery. So the direction of electric current is from the negative end to the positive end. This is what we call the conventional current, where the electric charges move from the positive end to the negative end. Now, the SI unit for measuring electric current is ampere. Its symbol is A. But the question here is, how much is a 1 ampere? To know this answer, let's start with what is an electric current made of. Each electron has only a very small amount of electric charge. The unit of the electric charge is coulomb, and the charge on one electron is minus 1.6 times 10 to the power minus 19 coulomb. So how many electrons are needed for the charge of 1 coulomb? You would need about 6,250 million billion or 6.25 times 10 to the power 18 electrons to have a charge of 1 coulomb. A current of 1 ampere flows in a wire if a charge of 1 coulomb passes any point in the wire each second. So 1 coulomb per second for 1 ampere is 6.25 times 10 to the power 18 electrons. The SI unit for measuring electric current is ampere A. So if we say that we have 2 ampere, we need double that amount, which is 2 coulomb per second, and double the amount of electrons. Now, you need to keep in mind that sometimes the electrons collide with the atoms in a material. Then the atoms gain energy from the collisions and vibrate. Just as you see in the video on the right, the continuous collisions and vibrations produces heat energy. This heat energy is the reason why some cables or plugs heat up sometimes. If the heat energy was huge, more than the allowed limit, this means that more electrons are flowing in the material and more collisions between electrons and atoms.